Energy. Energy is something that we talk about a lot in everyday life. You're like, man, I'm just really out of energy, right? I have to go to work. Well, we use those words a little differently in science. Energy can be defined as the capacity to do work. Well, what is work? Work is not something that you're getting paid to do. Work is defined as the action of a force through a distance. So I dropped this Sharpie marker on the floor earlier. I'm going to put it back on the floor. And if I give it a kick and I push it across the floor, I just did work. There's not going to be a bonus in my paycheck for that. But I exerted a force through a distance and I moved that pen. When I go and pick this pen up, I'm also exerting a force through a distance and doing work. Okay? Pushing a box across the floor, pedaling your bicycle, that's work scientifically. There are different kinds of energy. You can categorize energy. There's kinetic and potential and thermal energy. There are many other types of energy that we won't mention in this class, but we're just going to go over the ones you kind of need to know about. So kinetic energy is energy of motion. When something is in motion, it has kinetic energy. Potential energy is energy associated either with the position of something or with its composition. Okay, and so those are the two broad categories of energy, either due to motion or due to position or composition. So when I hold this Sharpie marker shoulder height, it has more potential energy than when I hold it closer to the floor. When I drop the marker, its potential energy gets transferred into kinetic energy as it picks up speed before it hits the floor. So thermal energy is a form of kinetic energy. It's energy associated with the temperature of an object. The temperature of an object has to do with the motion of the individual particles. So students here in the solid state, you have a temperature. It's how much you're moving. Right now I'd say you're pretty chill. You're not moving very much. But if everybody got all agitated and was flailing their arms and legs around, even though you're still sitting in your stools, right, you would have a higher kinetic energy. You're moving, you're just not moving relative to each other. So even a solid has movement. The particles in this bench top are moving. Look at it. Does it look like they're moving? We can't see them move because they're way too small, but they're moving. When you increase the temperature of something, you cause the particles in it to move faster. That's thermal energy. So energy, we'll learn, is also conserved. If you take this 10-pound weight, I prefer the cartoons where it was always a piano hanging out the second floor window. That's why they said, cartoons were violent. You take this 10-kilogram weight on the top of a building. It's sitting on the edge of the roof. That's not very stable. You give that thing a little shove, and what's going to happen? It's going to fall. Up here, it has high potential energy because it's unstable. As it begins to fall, it's going to go faster and faster and faster, but it's also getting lower to the ground. The lower it gets to the ground, the less potential energy it has, but it's going faster, so it's getting more and more kinetic energy. And then what happens to that energy when it hits the ground? It's dissipated as heat or thermal energy. That's something we're not necessarily aware of, because when stuff hits, you don't usually get the opportunity to feel the change in temperature caused by that. But when two large objects with a lot of kinetic energy collide with each other, they will actually get hot. So, law of conservation of energy. Similar to the law of conservation of mass, energy is neither created nor destroyed. You can change energy from one form to another. It can go from potential energy to kinetic energy, or the reverse. It can flow from one object to another. but the total quantity of energy is constant. So all the energy that's in the universe is all the energy that's in the universe. You can't make energy. You can just transfer it from one kind to another. Things that have high potential energy tend to be very unstable, and so they will tend to go to a lower potential energy, and in doing so, they will take that potential energy and convert it into other forms. So chemical energy is a form of potential energy. Chemical potential energy comes about because of the forces between the charged particles that make up the atoms and molecules of that substance. So gasoline has a great deal of potential energy. It's not very stable. You give a spark under the right conditions and it's going to explode. And the energy of that explosion can be very destructive, right? But the gasoline is just sitting there. You think of, it's like a time bomb, right? It's got all this stored up energy in there, and it's just going to erupt when it has the chance. Energy is always conserved in a physical or chemical change. Now, there are times where you can create energy from matter, and you could take energy and make it into matter. That's in nuclear chemistry, and we're not talking about that right now. We're talking about things that you could actually do in this room. Physical or chemical changes. The energy is neither created nor destroyed. And systems with high potential energy are going to tend to change in a way that lowers their potential energy and releases that energy into the surroundings. So that's what happens when I keep dropping the Sharpie marker, right? It's got high potential energy, and when I release it, it's unstable, it falls to the floor and transfers that potential energy into heat energy as it collides with the floor. That's not why it's so warm in the room. That amount of energy is very, very small. This happens in your car. So you put gasoline in the tank. Because of the interactions between the protons and the electrons in the gas molecules, it has high chemical potential energy. It's unstable. And so you run that through your engine, and you combust it, and it's going to go to a lower potential energy state. The exhaust molecules that come out the back afterwards are much lower in potential energy. They're much more stable than the gasoline that you put in. What happened to all that potential chemical energy? Well, hopefully a lot of it was harnessed to make your car move forward. What else happens to the temperature of your engine when you run your car? It gets hot. Turns out that every time you transfer energy from one kind to another, from potential to kinetic or kinetic to potential, there's going to be, we call it a loss of energy, but actually it's just energy that's transformed into a non-usable form. And often that is heat. So as your engine does its work, some of the energy that was originally stored in the gasoline gets lost to the environment as heat. But all the energy that you started with is present still in the universe afterwards. It's just some of it went as heat and some of it went as motion with your car. Any questions?